Dear students, physics is a mathematical science. The concepts and principles have mathematical basis. Throughout the course of our study of physics, we will encounter a variety of concepts that have a mathematical basis associated with them. Even though we will frequently focus on the conceptual aspects of physics, we will persistently and extensively address its mathematical side. Vectors is one such topic that I will introduce you today. The understanding of vectors is essential for quickly and easily solving many physics problems. In this video, I define some basic terms related to vectors and use them to solve few problems based on them. So first definition, physical quantity. A physical quantity is one that can be measured. In nature, measured. So few examples I given here. I cannot measure happiness. I cannot measure sadness. Such quantities are not called physical quantities. Here, mass can be measured. Such quantity is physical quantity. Here, physical quantities are classified into vectors and scalars. Scalar is a just real number. Can be negative, 0, or positive. Scalar quantity here, let us consider one brick. To measure its mass, I will write here 1 kg. Two such bricks are there, 2 kg. So different quantities will have different units. So here to mention how much it is, we are using scalar. And related to vector, it is having both magnitude and direction. Suppose person moved 5 meters. In which direction he moved 5 meters? We cannot represent exactly his motion unless he specifies the direction. If he says 5 meters towards east, since he mentioned direction, I can represent his motion exactly. So when we introduce something new, we have to define addition, multiplication, subtraction and all. Scalars are just numbers. So how we add numbers in the same way by using ordinary laws of algebra, we add them. Multiplication, all same. But here, in case of vectors, how to represent a vector? It is in general, books they will give bold letters. But when we are writing general letter or bold letter, we don't know. So what I suggest you is write S and arrow over it. So this is vector S. Say to represent a vector, we need 2 points. One is tail, other is head, and another is line segment. Line segment means part of a line. So this AB vector, I will write like this, or AB arrow mark. A to B, it gives you specific direction. So this is initial point, this is final point. That's how we represent a vector. And here operations on vector, like if I write AB bar and 2AB bar, here if I say AB, I will write like this. 2AB means there is a change in the magnitude. Direction means with respect to reference line, how much angle it makes. Once you multiply by a real number, what changes is there is no change in the angle, there is no only change occurs in the magnitude. And to represent a vector in the standard form, here they defined unit vectors along xyz direction. For one unit along x-axis, I. If it is 2 units, I will write 2I. Similarly, along y-axis, 1 unit j. These are standard unit vectors along xyz axis. Here, few examples of vector quantity, displacement, velocity, acceleration, these are examples. Here, person moved from A to B, and he can reach B in any path. So if he travels in this direction, arc length is the distance, but shortest length between AB is displacement. So here, I already told you, once we introduce new topic, we have to define addition, subtraction, and so here vectors cannot be added, subtracted, multiplied by ordinary laws of algebra. Why means a person moves 3 meters towards east and then he moved towards north 4 meters. So what is the displacement means? I cannot say 7 meters. So here we have to displacement is he traveled 3 meters in one direction along east. If I represent 1 unit by I, so here it is AC, I can represent it as 3I. Along y-axis for 1 unit J, I'll let CB is 4J. So this AB vector, finally I can write 3I plus 4J. So general algebraic addition is not meaningful here. To find displacement, we cannot add vectors like a scalar addition. So for that addition, how they defined is if two vectors, let us say AB, so directed towards B, here it's directed towards C. These are taken as two sides of a triangle. What is the resultant of these two vectors? So you are here, you've taken vectors in clockwise direction, but resultant will be in opposite direction. Its resultant is third side of a triangle, not in C to A. You have to take it as AC. That is why they say opposite order. That's how addition is defined. Here, very important point in vectors is What is the difference between point and a line vector? In fact, if you take a generally in coordinate system, one reference point we take, I'll write coordinates as 1, 2. That means with respect to this reference point, horizontally at 1 unit distance, vertically at 2 units distance. Here, point vector for 1 unit along x-axis, I write I. 1 unit along y-axis, I will write j. By vector addition, what is OP bar is OL bar plus LP bar, I plus 2j. So here it is a I plus 2j is a point vector. So here even line vector also seems to be same. Unless they mention that it is a point vector, we don't know whether it represents a line vector or point vector. For example, here if I take by earlier vector addition, AB bar, say to reach B, there is another path. I can write it as A to O plus O to B. Here it is OB. AO is in this direction. OA will be in opposite direction. So this line vector, I can write it as difference of 2 point vectors. If I take 2 points, one point as 1, 3, other point as 2, 5. If I write AB as OB minus OA, it is 2I plus 5J minus I plus 3J. Here also it is I plus 2J. If you observe carefully, both are I plus 2J. But this is a line vector here. It is a point vector. So by seeing vector, we are not in a position to decide whether it is a point vector or line vector. Generally, by default, vector means you have to say line vector. Even point vector also a potential vector with respect to reference point O. And here, when pair of points, another important point is vector has a magnitude and direction, but point has no direction, right? And vector has both magnitude and direction, but no fixed position. Suppose you take this as a line vector, some other 2 points I will take 1, 4, 2, 6. Even if I find CD, just difference I plus 2j. This says that vector has a magnitude means length of this, and a direction means it makes an angle, but no fixed position in space. I plus 2j may represent this, may represent this, may represent some other. So here, a vector joining 2 points, how to find out, I already discussed here. AB, this is one point in the plane, this is other point in the plane. So OB minus OA. Cartesian point of view, I write like this. Vector point of view, I'll write like this, which is here x2 minus x1 into I plus y2 minus y1 into j. This is what? That line vector. And the magnitude of a vector, where this is a vector, its magnitude is represented by like this. So modulus of AB, and it is defined as x2 minus x1 whole square plus y2 minus y1 whole square. So that one, even you can prove it here. If you take coordinate axis, x and y axis, and take 2 points p x1 y1, q as x2 y2, magnitude of this vector pq. So drop a perpendicular through q to x-axis and through p to x-axis. Say another line I'm drawing parallel to x-axis. Till here is x1, till here is x2. It will be x2 minus x1. Till here is y2, it is y1, y2 minus y. By Pythagoras theorem, so it is x2 minus x1 whole square plus y2 minus y1. So PQ will be x2 minus x1 whole square. This is nothing but distance between 2 points, which we call it as magnitude of a vector PQ. Here direction is nothing but measurement of an angle which is made with the horizontal line. It is a horizontal line. Here is a point x comma y. What is the direction which this QP vector with the reference line or horizontal line, say it as alpha. If you drop a perpendicular, it is y, it is x. Tan alpha is y by x. And here, if there are 2 points are given, how do we find the direction it made with the horizontal line? So it is a line which passing through 2 points x to it. What is the direction it made with the horizontal? So drop a perpendicular. This is y1. From here to here is y2. It is y1. It is y2 minus y. Till here is x2. It is x1. So tan theta will be opposite side to theta. Say this is AL. Y2 minus y1 by x2. Once you know 2 points, substitute here, we get angle made by that line with the horizontal line. So some more definitions. Equal vectors means same magnitude and direction. Suppose if you take a square, all sides are equal. But AB vector and BC vector are not equal because they have different direction. To be more clear, I will take square like this. So if I denote vertices with letters A, B, C, D, square means all sides same, but this angle made by AB and angle made by BC are different. Since their directions are different, AB and BC are not equal. But AB and DC are equal. Y means angle made by AB, DC is a parallel line. Angles will be same, magnitudes will be same. Such vectors are equal. Here, vectors, right, having same direction, but they differ in a magnitude, such vectors are called like or parallel vectors. If two vectors have opposite directions and different magnitudes are called unlike vectors or anti-parallel vectors. In this direction, if you write it as a bar, opposite direction we have to represent with minus a. Unit vector means having unit magnitude. Suppose if I take vector as like this, by earlier discussion, magnitude is this. So its length is not 1. So it is not a unit vector. To get unit vector in this direction, divide vector by its magnitude. Now you can check it. So is it this unit vector we denote with a cap? You check the magnitude. You get 25 by 25, which is 1. So here, if you take 2 points, so you can decide its direction. Here you take another point, you can decide its direction. Here you can decide its direction. Same point is there, which direction, this direction or this direction. Or so the direction of a null vector, that is null vector means AB here, I will write OB minus OA, AA. Here it is 0. It is called null vector. So we cannot decide its direction. So a vector which is different from 0 is called proper vector, whose magnitude is different from 0. Here, find the magnitude and direction of the vector. So let OB origin, let position vector of point A be 1, 2. I can write OA as I plus 2j. Let position vector of point B be 3, 4. OB bar I can write. Here we have to find vector joining these 2 points, final minus initial vector 3i plus 4j minus I plus 2j, 2i plus 2j. He is asking magnitude, which is 4 plus 4, 2 root. Direction concerned, 2 units along x-axis, 2 units. Tan theta here is y by x, theta is pi by 4. This is the direction. This is the magnitude. In a similar way, to find a unit vector, this point is represented with A, this is represented with B. AB we will write O as a reference point, 4i plus 8j. Here it is 3i plus 4j. He is asking unit vector along AB, which is AB bar by mod of AB bar, 3i plus 4j by, that is 3i plus 4j by 5. Here, southeast direction. This is east. Here is north. It is south. Sorry. It is west. And it is south. The line exactly in the middle, it's 45. This is the northeast. Here it is northwest. Here it is southwest. Here it is southeast. So southeast means finally we require this direction. So here it is 45 degrees. Say it is xy. Tan 45 will be y by x. So from here, y is x. How do I represent a vector? OP bar is OL bar plus LP bar. Xi, but LP is in this direction plus j. Here it is minus j. So what you have to find out is unit vector. Unit vector is OP bar by mod OP bar. Here x square plus x square root 2x. So answer will be here plus or minus I minus j by root. So unit vector in that direction. So only write plus. So northeast means it is east, it is north. So let us take one vector because 45, this and this will be equal. OP bar will be I plus j. It is not a unit vector because its magnitude 1 square plus 1 square root 2. Unit vector will be mod OP bar I plus j by root 2. It is unit vector, but he wants 5 units vector multiply with 5 to get 5 units vector. First unit vector to get 5 units vector multiply with. Here southwest direction. Southwest is here. So say this is OP, take a general vector, it is OQ will be OL plus LQ. So he is asking vector along which is having 32. First you find magnitude and unit vector OQ bar by mod of OQ bar, and you want 30 root 2 units vector. After getting unit vector, you want 32 root 2 units magnitude vector. Multiply with that, we get minus 30 times I plus j. Root 2 get cancels out. And here unit vector this already I discussed, east, north, west, south. Here 30 degrees north of east, that means east to north. That started from east and he is moving towards north by making an angle 30 degrees with east. That is east to north. How to find vector along OP? OLI, because for 1 unit it is I, for OL we don't know how many units. Let us say it has X units, it has Y units. Tan 30 will be Y by X. It's 1 by root 3. Y here is X by root 3. So OP bar, in place of OL I wrote X, in place of LP Y, which is X by root 3J. So to get a unit vector in northeast direction, that is not northeast, 30 degrees east of north. So here xi plus magnitude of it, x into I plus j by root 3, 3x square plus x square, 2x by root 3. Get cancel. Root 3I plus j by root 3. So the vector in that direction is this. So to do problems related to this, 30 person moves 30 meters north, okay? And 20 meters towards east, and then 30 root 2 meters southwest. East, west, north, south. Southwest. Southwest is like this. So that is 32 root 2 meters in southwest direction. So here AB his displacement from the original position. Initial position is this, final position is this. You have to find out displacement. So by using vectors, he moved 30 meters towards north. I will write J. And then towards east, I will write I. Southwest means this is minus I, minus J. So the vector along southwest is this, but he wants 30 root 2 meters. First we find unit vector and multiply it by 30 root 2. You get minus 30 into I plus J. So the final displacement will be shortest distance between initial and final point, A to B, B to C. Vectorial addition gives AC. Then C to D. So that means, which is nothing but AD. AB here is 30J, 20I minus 30 times I plus J. 30J get cancelled, minus 10I. So that means, so final displacement is 10 meters east I, west minus I, towards west. Suppose vector notation is not there. How do we tackle the same problem? So here it is AB, and then he moves towards right, east, 20 meters, and then 30 root 2 meters towards southwest. So here it is 20, it is 20. So it is the final displacement, this. And towards north, he moved 30. So DC square is, by Pythagoras theorem, I will write. DC is 30 root 2 whole square. If you take 30 square this side, x plus 20 whole square is 30 square, root 2 square is 2 minus. So x plus 2 is 30. That means 10 meters towards west. So this is how, without using vectors, with vectors. Here a person walks from point A to point B towards north, and then to the point C towards west. 200 meters, it is east, west, north, south. 200 meters south. And then finish at a point E, 700 meters east. Then to the point C. Okay. So this is the initial point, it is final point. So you can use vectors as well as direct method. So here it is 400, it will be 400. This will be 300 because total is 700. And A to B is 600. CD is 200. Then AL will be 600 minus 200, 400. Then final displacement will be distance between initial point and final point. AE square will be, this is 400 square plus 300 square. 16 plus 9. So AE will be 100 into 5, 500 meters. So without using vectors, with using vectors, first he reached B, then towards left he traveled something, then CD, then DE. Was the displacement, shortest distance between initial and final. AB in vertical direction, BC towards left we write CD downwards, DE towards positive side, 700I minus 400I, this one 400J. So AE will be root of 300 square plus 100 square if you take common, 9 plus 16, 100 into 5. So like this you can solve any problem by using vectors or directly, whatever you feel comfortable. Vectors is more comfortable, whatever the typical problem he gives. Here it is, walks 10 meters towards west. Say this is reference point, east, west. Here is north, south. So I'll use one method to solve the remaining problems. You solve by using other method. 10 meters towards west, 12 meters towards south, 15 meters towards east. This is initial, it is 5. So till here is 10 meters, it will be 5, it is 12. AB square will be totally 15, right? It is 5. 12 square plus 5 square, 169. So that will be the displacement from, you use vector method to solve the same problem. Here also 1 meter towards west, east, west, north, south. 1 meter towards west, 3 meters due south, and then 5 meters due east. So the final, earlier problem I did generally, now I will use vectors. AB towards left 1 unit, downwards minus J, towards right. So the magnitude of AD will be 5 meters. So last problem. Your object move 40 meters towards east. And then moves in a direction 37 degrees north of east. East, west, north. North of east means east to north. So like this. (37°). What is the displacement of the object? So here AB is the displacement. Shortest distance between initial point and final point. So in this direction, he moved 100 meters. Sin 37 value he given 0.6. 0.6 by is we can write 0.66 by 10, 3 by 5. 1 sin 37 is 3 by 5. By using Pythagoras theorem, 25 minus 9, 16, 4. Say this is x, it is y. AC will be 40 plus x. CB will be y. So by using cos 37, I can write x by 100. Cos 37 is 4 by 5. X will be 80 meters. Sin 37, 3 by 5, which is y here is 60 meters. Now to find out AB square, AC square plus CB square. AC is 40 plus x 80. CB is nothing but y 60 square. 120 whole square plus 60 square. If you take 60 square common 2 square, that is 60 square into 5, 60 root 5 meters. Okay. So for learners, this will be definitely useful. So try to understand by listening once. If you are not still following, go through it twice or thrice. Definitely you will gain knowledge. You will be in a position to do problems related to displacement with the vector approach.